So this is the second part of your final exam review. So units 5 and 6 have already been done, and we're working on unit 7 at this point. So unit 7 was all about the different transformations with quadratic functions. It also included linear and exponential functions. So when we look at this first section, the entire first section has to do with quadratics. So the thing to remember is that if there is something happening outside the parentheses, it affects your output values. If there's something happening inside the parentheses, it has to do with your input values. So on this first one, we have a -3 outside the parentheses. So that means your output values are decreasing by 3, which is going to shift your graph down 3 units. So when we look at all of these, we see that this one, graph A, has been moved up 3 units and reflected. So that's not it. Remember, those reflections have to do with that negative A value. So graph B has been moved left 3 units, and sometimes it's good to go ahead and write these things at the same time. So graph A was reflected and then up 3. Graph B was moved left 3. Graph C looks a little bit skinnier, so we're going to call this a vertical stretch. Graph D has been moved down 3. And graph E has been moved right 3. So if you make your observations, it'll make pointing out which graph goes with which equation a lot easier. So again, with number 7, it says y equals x squared minus 3. So those output values are decreasing by 3, which means it is moving down 3, which means that number 7 is graph D. So number 8, y equals quantity x minus 3 squared, means that it's affecting the inputs because it's inside the parentheses. Now, something we talked about several times in class is that inside you change your thinking. So where we see this -3, we need to think right 3 because we need to change it up. So this one is E because that one has been moved right 3 units. So number 9 is the opposite. We have a +3 inside the parentheses, so that input value, we have to change our thinking, and it's left 3, like graph B. So number 10, it has that negative A value, which means that it has a reflection. It also has the +3 on the end, which affects your output values because it's outside the parentheses. So this one has been reflected and shifted up 3 units, like A. And then the last one is your vertical stretch because the A value is greater than 1. So when A is greater than 1, it creates a vertical stretch because those output values get multiplied by 3. In the next section, we are describing the transformation happening with each equation. So the first thing I notice on this one is that the x is in the exponent, which means it's exponential. So I know that because it has a 2 as the base of an exponential, it is exponential growth. So then the other things I notice is that the 2 is negative, which means it's also reflected over the x-axis. Moving from left to right through the equation, and the exponent with your x variable inside the parentheses is a +5. Remember, we change our thinking inside, so that +5 actually tells us it's moved left 5. Input values are your x's, moves it left and right. So then we have our output change. So outside the parentheses, we have a -1. So this is down 1 because we don't change outside. So those are the 4 transformations happening to that one exponential growth function. So the next one, I also see that x is still in the exponent, which lets me know that this is an exponential function. X in the exponent for exponential. However, this one has a base of 1/2, so it is exponential decay. Because my base is half. It's a fraction. It's between 0 and 1. So then moving through the equation, I see in the exponent up here with x, there's a -1. Change your thinking inside, so that's right 1. And then the output changes that +3. We don't change outside, so it's just up 3. So the next one says, write the equation of a line that has been horizontally stretched by a scale factor 1/2. So I'm going to underline that. Translated 2 units left and 5 units down. So because this is a line, it's going to be in that y equals mx plus b formatting. So I'm going to write it out and then us change it accordingly. So y equals m. I'm going to put x in the parentheses because there is a horizontal shift, and plus b. So we can see that it has been horizontally stretched by a scale factor 1/2. So that means up in the front, that a value in the other equations is going to be 1/2. So then it says it's translated 2 units left. Left and right are your input values. You always change your thinking inside. So where our head wants to tell us that left 2 is -2, we have to change our thinking. And then 5 units down. So again, with the outside, you don't change outside. So our 5 units down is a -5. On to the next one. It says convert y equals 2 times quantity x plus 4 multiplied by quantity x minus 3 into standard form and into vertex form. So the first thing we have to do to get this into standard form is I like to distribute the 2, and that way when I set up my box thing, the area model, I have 2 binomials I'm multiplying and I don't have to go back and implement that 2 in. So I'm going to rewrite this as y equals 2x plus 8 times x minus 3. So now that I have that, I can go ahead and set up the box thing and multiply this into standard form. So we have 2x plus 8x minus 3. So remember when filling out the area model, you're multiplying. So 2x times x gives us 2x squared. 8 times x is a positive 8x. 2x times -3 is a -6x. And 8 times -3 is -24. So in standard form, we have y equals 2x squared, combine like terms, so 8x minus 6x is 2x, and bring over your minus 24. Now to get this into vertex form, we have to begin by finding our x value by doing -b over 2a. So our b value is 2, so we have -2 over 2 times your a value, which is also 2. So that means the x value in our vertex is -1/2 because it ends up -2 over 4, which is -1/2. So from there, we plug this back in to solve for our y value. So we have y equals 2 times -x squared plus 2 times -x minus 24. So each time I said x, I plugged in that -1/2 that we just solved for as our x value. And when you plug this into the calculator, you're going to get -24.5. So because that's a -24.5, I'm going to change my -1/2 to a -0.5 because they are the same. Now, the other thing to remember in vertex form is your a value. So when we write vertex form, straight from your formula sheet, it's y equals a times x minus h squared plus k. So your a value is the same as your a value in the equation in the standard form, so we put our 2 there. Your h is the same thing as your horizontal shift, which is your x value. So I'm going to replace that with the negative 0.5, but when you subtract a negative, you're actually adding. And then your k value is the y value of your vertex. So we have we have a negative 24.5, so minus 24.5. So again, from standard form, which is y equals ax squared plus bx plus c, which is this one right here, you do your negative b over 2a to find the x value of your vertex, plug it back in to find the y value, and then substitute in. So our next one says, Dewan deposits $1,200 into a bank account that earns 5% interest monthly. Which equation represents the amount of money in Dewan's account after t years? So this is the compound interest. So we have A equals P times 1 plus or minus, depending on growth or decay, R divided by N to the NT. So when we plug in everything we know, remember P is your principal, your initial amount. So our principal in this is that $1,200 deposit. The 1 just represents that you get to keep 100% of your money, and we are earning 5%. So 5% as a decimal is 0.05. So we're going to add 0.05. N is the number of times that it is compounded. So because this is compounded monthly, we're going to put that over N, and then N times T goes in your exponent. So N is the number of times it's compounded, and T is your amount of time. The next one says convert y equals negative 3 times quantity x plus 2 squared plus 8. So on this, the first thing I like to do is get rid of that exponent by rewriting this so that it's in a format that's a little easier to read. So we have y equals negative 3 times x plus 2 times x plus 2, because that's that x plus 2 squared, plus 8. So now at this point, I can go ahead and distribute that negative 3 into one of the binomials. So I have negative 3 times x and negative 3 times 2, and I end up with y equals negative 3x minus 6 times x plus 2 plus 8. So I need to do the box thing before I can add, because multiply comes before addition in PEMDAS in the order of operations. So we have negative 3x minus 6 times x plus 2. So negative 3x times x is negative 3x squared. Negative 6 times x is negative 6x. Negative 3x plus 2 is negative 6x. And then negative 6 times 2 is negative 12. There's our like term. So all we did was we took care of this. So we have y equals our simplified version, negative 3x squared, negative 6x minus 6x is negative 12x minus 12, and then we still have to bring down the plus 8. So combine like terms to get this from vertex form into standard form. And we have negative 3x squared minus 12x, and negative 12 plus 8 is negative 4. And there's your standard form. So now we're moving on to Unit 8, which is a lot of factoring. So the thing to remember with these questions is if your A value is 1, you have one less step to do. So for this, A is 1, so you 1 times C, A times C adds up to B. A times C adds up to B. That's what you guys need to remember. So 1 times 15 is 15. So we need to find the factors of 15 that add up to negative 8. Well, the only way you can make a positive product and a negative sum is if both numbers are negative. So if we try negative 1 times negative 15, that gives us a sum of negative 16. Our B value is negative 8, so that's not going to work. So then we have negative 3 times negative 5 gives us positive 15, And the sum of negative 3 and negative 5 is negative 8. There's our b value. So because a is 1, we can simply set up our two binomials. So the factors are negative 3 and negative 5. The next one says factor the following and watch out for GCFs, so greatest common factors. So I look at this and I have 3, 12, and negative 15 as the numbers. So I notice that I can factor out a 3 out of each of those things. So I bring down my 3 and I'm left with 3x squared divided by 3 is just x squared. 12x divided by 3 is 4x. And negative 15 divided by 3 is negative 5. So now I can figure out my a times b adds up to c. So a is 1, b is negative 5. The only way to make a product that's negative is if you multiply a positive times a negative. So I have 1 times negative 5, which gives me negative 4. That's not my b value. My b value is positive 4. So let's try negative 1 times positive 5, which gives me 4. So those are my factors. So don't forget your 3 when you bring this down. And again, because the a value is 1 and the trinomial I was factoring, I can just put my factors into the binomials. So the next one, a is still 1, so this is still simple. So a times c, 1 times 50 is 50. And I'm looking for two factors that add up to a positive 15. So they multiply to make a positive, they add to make a positive, which means they're both positive. So we have 1 times 50, which adds up to 51. We have 2 times 25, which adds up to 27. We have 5 times 10, which adds up to 15. So there's my b value. So there's my factors. So I have x and x. And then the two factors are positive 5 and positive 10. Positive 5 times positive 10 is positive 50. Positive 5 plus positive 10 is positive 15. So now we've got another one that has an a value that's not 1. So for this one, we still start out the same way. A times c, which is negative 24, and we want it to add up to b, which is negative 10. So remember, the only way to make a negative product is if one number is positive and the other one is negative. So I'm going to try, because my b value is negative, my bigger value is going to be negative. So I have 1 times negative 24, which adds up to negative 23, not my b value. So I have 2 times negative 12, which equals at negative 10. They have a sum of negative 10. So there's my b value. Now, because your a value is 3, not negative 1, we have to break it down into our box thing. So I like to write out all 4 terms of this before I set up the box thing, because then you can see where every part of the box thing come together. So I have 3x squared brought straight down from my equation. Now, using the factors, I said positive 2x and negative 12x makes up that negative 10x b value. And then I bring down that minus 8. So those are the 4 terms that go inside the area model. So we have 3x squared, positive 2x, negative 12x, and negative 8. And then we have to find the two binomials that make this make sense. So the first thing I look at typically is either that first row or first column, because we know there's always an x and an x here. So we have to figure out, what do these terms have in common? And it's a 3. And then we also can see that 3x times x makes that 3x squared that's in that box. So now 3x times something is going to make 12x squared. So 3x times negative 4 gives you negative 12x. So negative 4 goes here. So then I also see I've got a negative 4, negative 8. So negative 4 times something makes negative 8. So negative 4 times positive 2 equals negative 8. And then as a double check, 2 times x makes 2x. So because everything works out, you can double check by multiplying through the whole thing. But now I know that my binomials are 3x plus 2 and x minus 4. Now, this also tells us to solve. So in order to solve this, we would have to go back and set each binomial equal to 0, and then solve for x. So if we're going to solve this, we have 3x plus 2 equals 0. So to solve this, you subtract 2 from both sides. You're left with 3x equals negative 2. Divide by your 3, and x equals negative 2 over 3. Then for your second binomial, we set it equal to 0 as well. So we have x minus 4 equals 0. Add 4 to both sides, and you get x equals 4. So your solutions would be x equals negative 2/3 or 4. So on the next one, it says solve by completing the square. So to complete the square, the first step is to move c. So we're going to add 11 to both sides of the equation. So then we're left with x squared plus 10x. And because we're completing the square, we're going to be adding something to both sides. So we have 0 plus 11 is 11. And what you do to one side of the equation, you have to do to the other in order to keep it balanced. So now, to figure out what goes in this space, we have to do b divided by 2 squared. So your b value is 10, so we're doing 10 divided by 2, which is 5. Squared makes 25, so that's what we're adding to both sides. So that gives us, we can go ahead and break down this right side. We have, because we're completing the square, so to figure out what goes in this space is we actually just do the inside of this. So b divided by 2, so that's 10 divided by 2, which is 5. So x plus 5 quantity squared equals 36. Now we're not finished here. At this point, we have completed the square, but we need to still solve it. So in order to solve this, you do the square root of each side, and we're left with x plus 5 equals a positive or a negative 6, because the square root of 36 is 6. The reason it's a positive or a negative is because 6 times 6 is 36, and negative 6 times negative 6 is 36. So it can be a positive or a negative 6. So at this point, we need to finish solving it. So we break this down into two equations. X plus 5 equals positive 6, and x plus 5 equals negative 6. So when we solve these, we subtract 5 from both sides, so we get x equals 1. Subtract 5 from both sides on the second one, and x equals negative 11. So those are your two x values that are solutions to this quadratic. And remember, solutions, the x values are the same as your roots, your zeros, your x-intercepts. So this one says complete the square to rewrite in vertex form. So this is the same thing we just did, just one extra little step. So the first thing we still need to do is get c on the other side. So subtract 3, subtract 3. So we have y minus 3 on the left and x squared minus 8x on the right. Now we know we're going to add something to both sides. Remember, we're going to add that b over 2 squared. So negative 8 over 2 is negative 4. Squared is 16. So I'm going to add 16 to both sides of the equation. So now I'm left with y plus 13, because negative 3 plus 16 is 13, equals x squared, I'm going to go ahead and break it into my parentheses. So remember, what's inside here is what goes inside your parentheses. So we have negative 8 divided by 2 is negative 4 squared. And then to get it back into vertex form where y is by itself, we're going to subtract 13 from both sides, and we're left with y equals x minus 4 quantity squared minus 13. So this one says use the quadratic formula to find the zeros for the function. Zeros, x-intercept solutions, they're all synonymous. They all mean the same thing. So for the quadratic formula, the first thing you need to do is label your a, b, and c. And then we're plugging it straight into the quadratic formula, which is on your formula sheet. So we have negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So you plug this into the calculator one time with using the plus sign and another time with using the minus sign, and the two answers you're going to get is that x is equal to either negative 3 plus the square root of 89 over 8, or negative 3 minus the square root of 89 over 8. The next one says, calculate the discriminant and determine the number of solutions for the function. Remember, the discriminant is found by doing only what's under the square root symbol in the quadratic formula. So the discriminant is found by doing b squared minus 4ac. So you still have to label your parts. A is 1, b is 8, and c is 3. So to find our discriminant, we do b squared minus 4 times a times c. And when you plug that straight into the calculator, you're going to get a discriminant that is 52. Remember, a discriminant that is above 0 means it has two real solutions. So above 0 is 2, below 0 is none, and equal to 0 is 1. So on this one, same thing. Calculate the discriminant and determine the number of solutions. So your a value is 2, b value is negative 6, and the c value is 7. So our discriminant is b squared minus 4 times a times c. And when you plug that straight into the calculator, you're going to get the discriminant is equal to negative 20. And because that number is negative, it is no real solutions. So again, if it's positive, it's two real solutions. If it's negative, it's no real solutions. If it's equal to 0, it's one real solution. All right, last problem from this section. Sarah threw a stick from a bridge that was 32 feet above the water. The equation representing the path of the stick is f of t equals negative t squared plus 4t plus 32. And it says, how long did it take the stick to reach the maximum height? So if you think about the shape of this quadratic and the situation, if you throw a stick from a bridge and then it hits the water, so I'm going to make this blue like the water. So we're looking for how long it takes to reach the maximum height. which is your vertex. So the x value is always representing the time. So in this case, we just have to find the x value of the vertex. So to find that, you do negative b over 2a, which is everything that's outside the radical symbol in the quadratic formula. So your b value is 4, so we have negative 4 over 2, and your a value is negative 1. So negative 4 divided by negative 2 is a positive 2, which means that it took 2 seconds for the stick to reach the maximum height. So the next question says, what was the maximum height? So that's the y value of your vertex. So if we plug in our x value or t value of 2 seconds, we have negative t is 2 squared plus 4 times t is 2 plus 32. So when we plug that straight into a calculator, we get 36 feet, which means at 2 seconds, that stick is 36 feet in the air. And then it says, how long did it take for the stick to hit the water? So we have to plug this into the quadratic formula, because remember, where it hits the water is that x-intercept. It's the solution. It's the root. So to do that, we plug it into the quadratic formula. So we have negative, our b was 4, plus or minus the square root of b, which is 4, squared minus 4 times a was negative 1 times c is 32, all divided by 2 times a, which is negative 1. So when you plug this into the calculator, you're going to get two answers, negative 4 and 8. So we have to go back to the question and make sure it makes sense. So it says, how long did it take for the stick to hit the water? The stick's not going to hit the water at negative 4 seconds, so the 8 has to be our solution. So 8 seconds, and that stick will hit the water.